Event-driven architecture can transform how your systems talk, but how do you build one that still makes sense in a few years' time? Let's walk the whole journey, laying the foundations, the patterns inside, the trade-offs, and how to migrate. 4 chapters, 1 clear map. Chapter 1: The Foundations. Before you write a line of code, stop and understand your system. What actually happens in it? The events, the commands, the things your business cares about. Event storming is the workshop for this. You get your domain experts in a room with a wall of sticky notes, and together you map how the system really behaves. You agree on names, you find your aggregates, you surface every event. Clear, explicit names matter here. And this isn't a one-time thing. Come back to it as the system grows, so everyone keeps the same shared picture. Here's the mindset shift. Event-driven architecture is really just a collection of patterns. 2 families show up again and again. Messaging patterns move events around. Point-to-point, publish and subscribe, and event streaming. Over time, you'll use all of them. Integration patterns solve the awkward bits in between. The claim check for oversized payloads, the splitter for breaking a message apart, the translator for reshaping it. Most of these live in the Enterprise Integration Patterns book. Learn the vocabulary, and the whole architecture gets easier to reason about. The last foundation is the one people skip: living with this thing. Picture your architecture in 6 months, then 12, then 24. How will someone discover an event? Who produces it? Who consumes it? And what breaks if it changes? Document that early. Write down the producers and the consumers. Set standards for what every event must carry, and maybe ship a small internal toolkit so teams build them the same way. Spend a little time now on the problems you can already see coming. Chapter 2: Inside a Real Architecture. You never use just one pattern, you blend many. Start with the process manager. Think of it as a conductor. It owns a workflow and runs the business logic step by step, firing events to other services as it goes. When an order needs payment, then packing, then shipping, the process manager keeps that flow on track. AWS Step Functions is a classic example. Next, event sourcing. Instead of storing only the latest state, you store every event that ever happened and replay them to calculate state. It's like a bank statement. You don't just see the balance, you see every transaction that produced it. Downstream services can build their own views from the same history, and you get a complete audit trail for free. A common home for these events is a database like Amazon DynamoDB. Event streaming is for information in motion. Messages land on a continuous stream, and consumers choose where to start reading, tracking their place with an offset. Picture a ticker tape. The data keeps flowing, and each reader follows along at its own pace. This shines for real-time work, like reacting to clicks and user activity as they happen. Amazon Kinesis is a typical choice. Point-to-point messaging is the workhorse. A producer drops a message on a queue, and a consumer picks it up to process. Add more consumers and they share the load, each taking the next message, like a line of cashiers serving one queue of customers. It's simple, and it scales beautifully. Amazon SQS is the obvious example. Change data capture lets you react the moment your data changes. Every insert, update, or delete becomes an event, and consumers hook into that stream to do their work. It's a tap on the shoulder from your database whenever something moves. No polling, no guessing what changed. DynamoDB can emit these change streams straight out of the box. And publish and subscribe ties it together. A producer broadcasts an event, and every interested consumer gets its own copy. Fan it out to as many as you like. It's a radio station, transmitting once while everyone tunes in. This is how you decouple teams and let new consumers appear without ever touching the producer. Amazon Event Bridge is built for exactly this. Chapter 3: The Good, the Bad, and the Ugly. First, the good. Flexibility. Consumers can come and go, and new requirements just mean a new listener. Never a rewrite of the producer. Speed. Many flows can run in real time, or close to it, which can mean a better experience for your users. And fault tolerance. because consumers are decoupled. When one fails, the failure stays contained right there instead of taking everything down with it. Now the hard parts, the ones worth planning for. Error handling. When something fails, can you catch it before it's gone? A dead letter queue gives those events somewhere to wait. Debugging. Your producers and consumers are spread out by design, so tracing a single flow across them takes real effort and good tooling. And idempotency. Assume every event can arrive twice. Make sure a replay leaves the same result, with no nasty side effects. Chapter 4. Getting there. Software is never finished. Requirements shift, technology shifts, patterns shift. Event-driven architecture helps you adapt, but you don't arrive overnight. It's a journey, technical and organizational, and like all software, the work continues. If you're sitting on legacy code, you don't rewrite everything at once. Start with event storming to understand the behavior. Then raise a few simple events and a consumer or two. Find the natural boundaries in your domain and let services talk through events. Grow the producers and consumers over time. Start small and let it spread. Identify your events, combine the patterns, respect the trade-offs, and migrate one step at a time. That's event-driven architecture that lasts. If this helped, subscribe for more. Explained simply.